we're going to talk about the difference between statistics and machine learning. The point of statistics, what is it? Well, generally, it's to learn things from data. Fabulous. Machine learning, on the other hand, now the point is to learn from data. Okay. Specifically in statistics, we are going to create a mathematical formalization of relationships between variables. If you've seen my linear regression videos, you've seen those mathematical formulations. And we're going to express that formulation in the form of models that we will then specify for our computer and test it with our data. In machine learning, we're doing things a little bit differently. Finally, something's different. All right. So we're going to use algorithms to learn from data, basically recognize and memorize patterns and replicate those patterns. Big dig on what learning means in terms of computers. And we're going to do that without necessarily specifying the model at the outset. We might say, hey, here are the variables I want you to consider, and the computer is going to find the relationship. The primary goal, this is where I'm going to start to get in trouble. In my view, or at least in my own work, I tend to use stats. I'll use a statistical approach if I want to make an inference. I'm going to say, why is climate change happening? What is the relationship between, say, education and health outcomes? What policies reduce poverty at the community level? Why did people like fidget spinners? And why did they go away? Do you remember this? This was like a whole thing for some time. The primary goal for machine learning, or what I would turn to machine learning for rather than statistics, is if I really want to make some predictions. Stats can get us there. I'm not saying it can't, okay? I typically use machine learning if I'm trying to make a prediction. So what will the mean annual temperature in New York City be in 50 years? Forget the weather tomorrow. I need to know what's going on in 50 years. How long will people with a college education live compared to those without? Morbid. What will the poverty rates be in each borough of New York City in 10 years? How many fidget spinners are we going to sell next year? Honestly, it's relatively trivial in code to do both in many cases, not always, in many cases. And you can see our free online textbook for examples of code for doing either one. So there's usually no harm in doing both. But once we're working with massive data sets, of course, the choice has a little more weight to it. All right. Let's talk about the origin story of statistics. This is going to be the world's fastest and least satisfying review of the history of very big areas of thought and research. So stats comes from math, hundreds and hundreds and hundreds of years of math. It was once upon a time called the mathematics of collections of observations. I like how on the nose that is. The trade-offs when we do statistics there are more, but here are some big ones. We have to think carefully about how the data was measured and collected. We need to formulate a model of how our variables of interest are related. And we have to understand things in the output, like p-values and the coefficients and more. We need to also think about things like uncertainty, model fit, data generating process, the underlying distribution, and so on and so on. So there's lots to think about to properly do statistics, or to do statistics in a responsible way. But it might be worth it because we do get a better understanding of the relationship between variables, typically in stats. The origin story of machine learning is a little bit more recent than statistics. It was born from computer science and research in artificial intelligence, which is a term IBM invented in 1959. I believe it was Mrs. Maisel's father who invented that term. And it was then kind of ignored for a few decades because we all thought this is never going to work. And then in the 90s, it came back. It's based on this deep idea that computers can learn from data. When we do machine learning, we should think about all the same things about where the data came from, whether it's any good. We tend not to, largely because when I see machine learning implemented in the corporate world, for example, we're usually on a deadline and have a limited budget, and we kind of just need to get to some results. This is going to be bad, but if we have a machine learning training and not as much statistics training, or we have a machine learning computational training, but less of a research design training, we may just not know to think about those things. We just get data and we do things with it. But more often than not, we are given data at our jobs and we don't really have the luxury of saying, well, is this any good? It's not necessary in machine learning to have prior assumptions about the relationships between the variables. That's liberating. We do tend to need a lot of data. More data is generally better for both, but machine learning really thrives on it. But the output can be a black box. We won't necessarily know why the prediction is what it is. We'll just kind of know what the prediction is. We may not walk away with a better understanding of the relationship between underlying variables. None of these things are mutually exclusive. I'm getting worked up. But these are on average. This is what I think about when approaching a problem. All right, so I'm sitting down. I have a data set. Should I be approaching it with a statistics lens or machine learning lens? And suppose I have to choose. Again, I would do both if I could, when I can. As with most choices in data science and in life, it depends on the underlying data, what we're trying to do, and what's available to us in our skill set. If you don't know how to do machine learning, I would recommend starting with statistics. Just Just put my old professor hat on. All right. I like to think of data science as a bridge between the two worlds. So machine learning experts can help, maybe who traditionally have more of a computer science background, can help us build algorithms to make predictions that we hope are good. And statisticians can help us think about the underlying data, the possibilities for causal inference. I'm just being so general. And data scientists can bring the two together once and for all. We will see you in the next video.